to another A-level computer science video with me, Mr Goff, for MrGoff.com. This video will focus on comparing algorithms. Two ways that we compare algorithms are time complexity, that is, the time it will take for the algorithm to execute, and space complexity, that is, the amount of memory required during the execution of the algorithm. If you can recall the bubble sort and merge sort algorithms that we learned at GCSE, you will recall that for large sets, the bubble sort has a very high time complexity but a low space complexity, whereas the merge sort has a low time complexity but a very high space complexity. Time complexity can be expressed as a function based on the relative size of the problem. Some of the types of function that may be expressed are linear, polynomial, exponential, and logarithmic. We're going to take a look at each of these in more detail now. Linear functions are generally expressed in the form function of x is equal to ax plus b. As the value of x increases, the relative value of the constant b added to the first term is less and less relevant to the total that is reached. We can see that x is the dominant term in these functions. Polynomial functions are generally expressed in the form function of x is equal to ax squared plus bx plus c. As the value of x increases, the relative value of the bx and the constant c added to the first term are less and less relevant. We can see from this example that the dominant term here is x squared. Exponential functions are expressed in the form function of x equals ab to the power of x. Exponential functions become very large very quickly as the size of x grows, as you can see by this example here. Logarithmic functions take the form of function of x is equal to a log n x. The log of a number is the power you would have to raise the base to in order to reach it. As you can see in this example, increasing the value of x has a limited effect on logarithmic functions. Permutations refers to the number of ways of arranging a set of objects. For example, the number of different ways that you could seat guests at a wedding. The formula to calculate the number of permutations of a set of objects is the number of permutations for set size n is n factorial. Factorial is where you take that number and multiply it by every number down to 1 until we get the value. So 5 factorial would be 5 times 4 times 3 times 2 times 1, which is 120. As you might gather, this gets very large very quickly as the size of n increases. Big O notation is used to describe the time complexity of algorithms. A big O score of 01 means constant time. This is an algorithm like length equals len array that would take the same amount of time to execute regardless of the size of the array. ON means linear time. A linear search has a linear time complexity because its worst case scenario increases with the number of elements. ON squared refers to polynomial time. A nested loop where each runs n times would execute the outer loop n times, and each time through execute the inner loop n times, giving a value of n squared. O2n is exponential time. This refers to an algorithm that doubles in execution time for each new element, such as a recursive solution to outputting Fibonacci to n places. O log n refers to logarithmic time. The binary search algorithm is an example of logarithmic time where increasing the number of elements has little effect on the execution time. O n factorial is factorial time. Trying to solve the travelling salesman problem using a brute force approach would mean calculating every permutation of ways to visit n towns. You will need to be able to describe big O time complexities and identify the big O time complexity of a given algorithm. That brings us to the end of this video comparing algorithms. Join me in the next video when I'll be looking at the computability of algorithms. Use the resources at mrgoff.com to help you revise computer science. And until next time, it's bye for now.